Hello, ladies and gentlemen, and welcome back. We're looking now at question 3 on the Euclid paper from 2006. So we have a light bulb part to the question and a written part to the question. A. Determine the coordinates of the vertex of the parabola y equals x minus 20 and x minus 22. Okay, so what we've got our parabola here in is root form. So I know that the roots are at x equals 20 and x equals 22. Some people call them roots, some people call them zeros. That's all fine. But what it actually means for graphing the parabola the parabola looks a little something like this. We have a vertex here, and the vertex always lies halfway between the roots on what's called the line of symmetry, or the axis of symmetry. Okay? And about this vertical line, our parabolas are symmetric. You get a root over here, you get a root over here. So the x-coordinate of the vertex, and this is true not just for upward-facing parabolas like I have pictured, but also for downward-facing parabolas. So the x-coordinate of the vertex is the average of the roots. So it's going to be 20 plus 22 over 2, or 21. Now that I know that that is the x-coordinate, we can find the y-coordinate by plugging in 21 into our equation. I'll get 1 times -1, or -1. So we're going to have 21 and -1 are the coordinates. And we've justified everything in case we made a little arithmetic error. We even have a nice picture. Okay? And that's really all we need. For A part, just the 21 minus 1 would do, but to hedge our bets, we have the time, it didn't take that long, we write up a little bit so we can get part marks if we made a goof. Alright, so now B is where we actually have to justify everything, and where our practice of writing everything up is actually going to come into play. That's part of why I write up the light bulbs. It's great practice on your own to just practice your writing skills. Often the light bulb ones only need a little bit of justification, so it doesn't take too much out of your day. And it's great practice for how you write mathematically for these written parts. Point A is the vertex of parabola y equals x squared plus 2. Point B is the vertex of parabola y equals x squared minus 6x plus 7. So our first parabola is in vertex form, and I can see that the vertex, the point A is going to be at 0, 2. But the second parabola is in standard form. It's not in vertex form. So we may have to complete the square to find out exactly where B lies. And so we're not finished here, but O is going to denote the origin, so 0, 0. Determine the area of AOB, that triangle. All right. So I'm hoping our triangle is right-angled, and it might be. I mean, the x-y axes meet at a 90 degree at the origin, and our A, I already said, is at 0, 2. Let's get our second parabola in vertex form, and we'll see where it goes. So we have to write everything up. I would start by saying y equals x squared plus 2 is in vertex form. So A is at 0, 2. Nothing we need to worry about. We don't need to explain how to transfer things over from vertex form. Just point out it's in vertex form. I know how to read, so there it is. Now, our second one is x squared. I think it's minus 6x plus 7, or maybe it was plus 6x. No, minus 6x. So I'm going to complete the square. Half of 6 is 3. So I will add on 3 squared and subtract off 3 squared. Now x squared minus 6x plus 3 becomes negative 3x minus 3 squared. And then we're left with minus 9 plus 7, so this will be at negative 2. And this is also in vertex form. So b is at 3, negative 2. All right, so we're not quite going to get the right-angled triangle I had hoped for, because b doesn't lie anywhere on the x-axis. Let's draw what the triangle looks like. So we have the origin O here at 0, 0. We have A up here at 0, 2. And then we go over by 3 units and down by 2 units. So B here will be at 3, negative 2. So that gives us our coordinates. We draw a helpful little picture. And now I like that A is flat up against the side here. It makes determining AO really, really quick. It's going to be 2. And our triangle doesn't look like a nice, easy one to calculate with. But the fact that we have this flat base here, and yes, this is a base. I know it's looking vertical, but really any side can be a base if you want it to be. We know this length is 2. And if we were to just drop an altitude, suddenly we have the height. So we're going to write some of this up. AO equals 2. If you want to say something else about that, you might say, well, it's the difference in the y coordinates. But you don't need to justify a whole lot there. We just state that the length between A and O is 2. Let AO be a base. Then the height of triangle AOB can be found by measuring the horizontal distance from the y-axis to B. And if you want to, you can justify this a bit more. The picture certainly helps, but you can say AO is on the y-axis, so that's why it's the distance from the y-axis to B. All that's fine. But this is just the x-coordinate of B, which is going to be equal to 3. So we can conclude the area of triangle AOB is 1/2 base times height, and the 2's cancel out and we get 3 as our answer. Okay. So not so bad. We had to put some things together. Both parts of this question were about parabolas and their vertices. We did have to change a parabola into vertex form by completing the square, although you probably could have used the same technique as in A and maybe factored this. What would it factor to exactly? 2 numbers that multiply to 7 and add to negative 6. Well, I'm thinking negative 7 and 1, but that wouldn't give me plus 7 there. Actually, this has got me a little intrigued. When in doubt, quadratic formula, so negative b plus or minus the square root of b squared minus 4ac. 36 minus 28 is 8, so it's 6 plus or minus root 8 all over 2. Okay, so maybe quadratic formula or factoring wouldn't have worked out so nicely. It'll be 3 plus or minus root 2, by the way. But that wouldn't have exactly helped. So we really did have to change it to vertex form here. And that would be another way we could have done a part, is multiply the root form out into standard form and then complete the square from there. But so we splitted the square, got the points b, and then it was up to us, and I think the picture really helps to realize, oh, AO can be a base, and so then we just need to get a height, and that's actually not so bad. Okay, so that was question 3. I liked it. Nice little question. Join me in the next video for question number 4, and until then, have yourselves a wonderful day.